Hello all. In today's class of the cardiovascular physiology, we are going to discuss about one of the very important topic, which is the absolute refractory period and relative refractory period. So let me first discuss about what is the absolute refractory period. So the absolute refractory period is a time during which the cardiac cell cannot be re-excited no matter how strong the external stimulus is. So in other words to say that it is absolutely unresponsive to any of the incoming impulses. So what is the mechanism? For example, if you know the action potential of the cardiac muscle, so shortly after a cell depolarizes, especially during phase 0 and phase 1 of the action potential of the cardiac muscle, and often extending through most of the phase 2, what happens is the voltage gated sodium channels are either fully open or inactivated. So when sodium channels are inactivated, they cannot be opened again until the membrane potential repolarizes sufficiently to reset them. And the calcium channels in the myocardial cells, especially in the plateau phase of the action potential, also contribute to this period because as long as the membrane remains depolarized, it is very difficult for a new action potential to be generated. So this is the reason why absolute refractory period what is appreciated in the cardiac cell. So now, okay, we have the absolute refractory period. So what do you think is the physiological role of this period? So this particular period ensures that once a wave of depolarizes has started and the muscle is contracting, you cannot trigger another full blown contraction prematurely. So, it is actually considered as a protective mechanism that prevents tetany, that is, sustained contraction in the heart, ensuring rhythmic single contraction that allows the proper filling and ejection of the blood. So, this is where the absolute refractory period is absolutely essential. So, now, what is the clinical importance of this period? So, remember, guys, that during this absolute refractory period, any attempt to deliver an external shock or stray impulse won't trigger a new action potential. So, this is one particular reason why certain forms of external stimuli, like synchronized cardioversion, are timed to avoid hitting the vulnerable phases of repolarization. So I hope you have understood this is called as absolute refractory period. Now after understanding the absolute refractory period, now let us discuss about a relative refractory period. So after the absolute refractory period ends, the cell enters the relative refractory period when it can be excited by stimulus, but only if that stimulus is stronger than usual. Minimal stimulus can't be excited in this period. So the cell is still partially repolarized, which means some but not all the sodium and calcium channels are reset. Right? This is the relative refractory period. So what is the mechanism of this period? So if you see again the cardiac action potential graph over here, the membrane potential is slowly returning towards its resting level, mostly in the phase 2 and phase 3. So, a fraction of ion channels have recovered from inactivation and are capable of opening again, but the membrane is not fully stabilized. This is what you have to remember for relative refractory period. So, because fewer channels are available and the membrane is still partially depolarized, a higher intensity stimulus is actually required to trigger another action potential. So, this is what you need to know about the relative refractory period. Now, let us discuss what is the physiological role of the relative refractory period. Remember, guys, this period allows the cell to gradually regain excitability. If a significant ectopic beat or strong depolarizing current arrives here, it can trigger an early contraction. In a normal setting, these strong impulses are not typically present, so the heart continues in its usual rhythm. But however, in arrhythmogenic focus, if it fires at the right time during this particular phase, it can set off premature beats that can lead to more complex arrhythmias, right? So, what is the clinical relevance of this period here? Remember that this is the period during which a poorly timed shock, that is, hitting the T wave on ECG, might induce a dangerous arrhythmia like ventricular fibrillation. That's the reason synchronized cardioversion avoids delivering a shock during the relative refractory period. This is very important for all of you to know. So, putting all together, guys, the absolute refractory period safeguards the heart from immediate re excitation, while the relative refractory period gradually opens the door to possible new excitations, but only if the stimulus is strong enough. So, these two back to back time frames ensure a well coordinated rhythmic heartbeat. So, this is what we need to know about the absolute as well as relative refractory periods.